Hello again. This is part 2 of the video. So, you already worked out all the problems. I have it blank just to make it nice and clear. But your paper probably looks something like this. I've solved for x and/or I've solved for the angles and I've plugged those back in and checked it. Okay, so now we need to also add to our instructions, part 2 of the video, find the measure of each angle, and we want to, this part of the video, focus on list the angle relationships. Okay, so I'm going to just look through my whole paper and look for this relationship, which is actually, if I look at my notes, a linear pair. That's when two lines together form, two angles together, add up to 180, and they do touch. So notice I have this common side, and I can highlight this common side, right? Okay. So I'm going to look for that. It doesn't look like they have a common side there, so I'm going to keep going. Ooh, this one does look like they have a common side. So it looks like they have an obtuse angle and an acute, and together they form a straight line, and they definitely have a common side. So this one I'm going to call a linear pair. Okay, I'm going to keep looking. Nope, those are not touching. Not touching. Nope, not touching, not touching, not touching, not touching. Not touching, not touching. I'm still looking for my linear pairs. Not touching, not touching, not touching, not touching. Ooh, they're across from each other, but they're not. Ooh, oh, here it is. They're together, these two angles form a straight line. There's that common side. One is acute, one is obtuse. Okay, so that picture matches my picture over here on my linear pair. Right, I'm going to highlight that in my notes, and notice that those pictures look the same. Like that is what I found here in question 2 and here in question 16. So I'm going to write linear pair. Okay. Okay. Now, I found it again. There it is, linear pair. Oh, there it is again, linear pair. All right. Oh, linear pair. They're definitely touching. I'm just going to trace that. Oh, linear pair. Wow. So we didn't have any linear pairs, and then all of a sudden on the second page we had a whole bunch of linear pairs. So let's go back. It shows an acute angle, touching, and obtuse angle, and together they form a straight line. An acute angle is touching an obtuse angle, and together they form a straight line. An acute angle is touching an obtuse angle, and together they form a straight line. An obtuse angle and an acute angle are touching, and together they form a straight line. All of these, I'm going to put linear pair, linear pair, linear pair, and linear pair. Okay. Breathe in, breathe out. We got to go look for something else. I got to look for something else. And so I think I might be looking, I think I already saw this across from stuff. This is across from, if that's not in your notes. So notice 100 is across the vertex from 100. Those are vertical. I could turn my paper this way. 80 is across from 80. So I'm kind of looking for that, and then I'm going to call that vertical. Oh, I did it. The obtuse is across from the obtuse. That's definitely called vertical. Whoop. Okay. Nope, not across. This one is not across. Nothing is across from this. Nothing is across from that. Nothing is across. Nothing is across. Nope, 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 nope. Nothing's across. 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 Oh boy. Nothing's across. Nothing's across. Nothing's across. Nothing's across. Nothing's across. Nothing is across. Nope. Nothing's across. Nothing's across. Up. Finally. This one is across from that one. This one's across, so I'm going to call that vertical. Awesome sauce. Okay. And the rest of these were linear pair. So now I think I've searched for everything on this page. Now I'm going to search for some of these. Now these can be pretty hard. But the way I make it easier is I just shade in it. So I want to just take a pencil. Let me get up and get a pencil. Stand by. I'm going to go back to my seat with my pencil. And I'm going to shade my road. This is going to help me find out if they're see, I didn't shade both of the angles, but yeah, that one's linear or vertical. Shade my road. Nope, I already know the name of that one. Shade my road. Oh, both got shaded, so I need interior in my name. Shaded my road. Both angles got shaded, so I need interior in my name. Ooh, only one of them got shaded. So no interior. I'm just going to put a little eye out here. No interior and no exterior because they both are not outside either. Nope. Okay. Ooh, look there. Both of them are outside. And that's called exterior. So I know I'm going to have exterior in my name. Shade na. Ooh, both are exterior. So I'm going to write exterior. Shading them. Both got shaded. So I'm going to call that interior. Shade. Both did not get shaded. So that's exterior. Shade. Both got shaded. So that's interior. They're both in the road. Continue. Shade. Uh-oh. One got shaded, one didn't. So it's not going to be interior and it's not going to be exterior. Both got shaded. So that's going to be interior. Neither got shaded. Both of them are exterior out of the road. Shade. Both got shaded. So that's going to be interior. Okay, that's done. Now I could shade these, but I already have a name for these. I know that they don't have a name, interior or exterior. Okay, so I did that. Now I need to highlight my transversal. So because either you're on alternate sides of this transversal or you're on the same side. Okay, so I'm going to highlight my transversal, and this is on the left and that one's on the left, so that's the same side. Good. I'm going to trace my transversal. One's on the left, one's on the right, so that's on an alternate sides. Okay, one's on the left, one's on the right, so I wrote alternate. Ooh. It's not interior or exterior. They're on the same side of the road, but I can't use any of the alternate interior angle theorems or the exterior or the same side interior or this. Notice how all these names say interior, exterior, interior, exterior. So the only thing I have left is cap. So I'm going to put cap, corresponding angle postulate. This is what I call my slider fence. If I slid this guy off the road, he'd land right there. Okay, exterior. Trace my transversal. One's on the left, one's on the right, so I'm going to call that alternate. Trace the transversal. One is on the left, one is on the right of my green line. Alternate. Trace the line. One angle is on the left, one angle is on the right. Trace the line. One's on the left, one's on the right. Trace the line. One's on the left, one's on the right. That's alternate. Ooh, I can't use anything with interior, anything exterior, so the only thing I have left to choose from is corresponding. This thing was on the road and they slid it off the road. On the road, slid off the road. Okay, trace my line. One's on the left, one's on the right. Trace my line. One's on the left, one's on the right. Trace my line. Ooh, goody goody. Both of them are on the left, so that's called same side. So just to review, it looks like I came up with a name for everybody. Everybody has a name. I'm just going to make sure they're all boxed out. Looking good. Now, normally we finish this off same side interior angle theorem. Anything with a same side or an alternate has an extra AT at the end. So I'm just going to add that. Alternate exterior angle theorem. AT, short for angle theorem. Angle theorem. Cap is different. This one, anything alternate or anything same side is called an angle theorem. Angle theorem. Okay, now I'm done. Last step, just so it's going to be easy for me to grade. I got all my answers, and with some type of a highlighter, I'd like you to go back in and highlight all your angle relationships, making it easy for me to see your final answer. Thanks for joining us.